Hey guys, so I wanted to just finish out the 7.1 notes that we didn't get to in class. So we have a theorem that says a rational number, which just means a fraction in the simplest form, a over b, can be written as a terminating decimal if and only if the prime factorization of the denominators contains no primes other than 2 and 5. So a few things to make note of. The fact that the fraction is in simplest form. So you must reduce the fractions first and then do the factorization. And so prime factorization, this is a factor tree. And what you're going to do is you're just going to break down the number until you can't break it down anymore. And then in English, the prime factorization of the denominator in simplest form can only contain the numbers 2 and 5, meaning you can't see 3s, can't see 7s, can't see 5s, contains no other primes other than 2 or 5. So let's look at the first one. The first one is 3 over 5, which this fraction is already in simplest forms. 3 and 5 doesn't reduce down anymore. So I'm going to take the denominator, and the denominator itself is already prime. So it does not break down into anything except 1 and 5. And so our theorem says that if the denominator only contains 2's and or 5's, then it can be written as a terminating decimal. So 3 over 5, yes, this can be written as a terminating decimal. All right, so let's look at the next one. 3 over 15. Well, first off, I notice that it can simplify. 3 over 15, I can divide top and bottom by 3. So I'm going to simplify first, which is going to give me 1 over 5. And now I look at that denominator. That denominator is 5, which 5 is already prime, and it doesn't contain anything other than 2 and 5. So I can say that, yes, this can be written as a terminating decimal. All right, the next one, 1 over 5 to the third. Well, 5 to the third means 5 times 5 times 5. And so 5 is all prime. It doesn't contain anything other than 2 or 5. So I can say that, yes, this can be written as a terminating decimal. All right, let's look at some that may look a little different. 8 over 51. So first I'm looking for, can 8 and 51 simplify? Well, it can't. And so 8 over 51 doesn't reduce, so I can go straight to looking at the denominator and breaking it down. So I've got 51. Well, 51 is 3 times 17. 3 is prime. 17 is prime. But the theorem says, let's go back up. The theorem says that the prime factorization of the denominator, cannot contain anything other than 2's or 5's. So what I rewrote it as, it must contain only 2's and 5's. Well, if you see in my prime factorization, in my factor tree, it contains a 17 and it contains a 3. So does it contain something other than 2's and 5's? Yes. And so because it contains something other than 3 and 15, we're going to say not a terminating decimal. Again, the theorem says that the prime factorization of the denominator in simplest form can only contain 2's and 5's. This one does not only contain 2's and 5's. It actually doesn't contain either, so it cannot be written as a decimal. Whereas these other 3 on top only contained 2s and or 5s. In that case, they only contained 5s. So let's look at this one. 201, 625. Does it reduce? No. So I go straight to the prime factorization. So I'm going to write the prime factorization of 625, which just means do a factor tree. So 5 and 125 multiply to 625. Well, 5 is prime, so I can't break it down, but 125 I can break down to 5 and 25, and then 25 I can break down to 5 and 5. Something about prime factorization, it doesn't matter which numbers you pick up here as long as they do actually multiply to 25. So you could have different numbers all through here, but all of these will be the same. You'll still have 4 5s, you just may have a different order of numbers. So now I'm looking at the prime factorization. Well, this is the prime factorization. It's the prime part. And the property says if the prime factorization, so I'm up here again, if the prime factorization contains only 2s and 5s, then it can be written as a terminating decimal. Well, this prime factorization only contains 5s, so I can say yes, it can be written as a terminating decimal. All right, let's look at the last one. 17 over 2 to the 5th times 5. Well, if you want to write that out, that means 2 times 2 times 2 times 2 times 2. And of course, that means times 5. Well, because it can't reduce down any, I'm looking at the denominator. And the denominator, which is this, written out, is that one on the bottom, this 2 times 2 times 2 times 2 times 5. Again, my property says that the prime factorization of the denominator in simplest form can only contain the prime numbers 2 and 5. Does this denominator only contain 2s and 5s? Yes, so it can be written as a terminating decimal. All right, the last thing we're going to do is just kind of finish up a few more examples of what we did in class. I told you guys in class that I would recommend using method 1. It just seems to make more sense to students. But you do have the mental math where you say the numbers out loud, all to the same decimal place, and then the number line. Number line's not real great because some of these numbers are really, really tiny, and so you're drawing just a bunch of tick marks. We're going to do the -1 last, but let's look at number 2. We didn't get to it in class. First thing says to line up all the decimal points. So I've got 13.4919, 13.49183, and 13.49199. Notice not only are all the decimals lined up, but all the numbers are lined up as well. So you want to keep all of that stuff organized. Step 2 said to add in any zeros. Well, I do have a blank right here, so I need to add in a placeholder of a 0. And then step 3 said, well, find where the numbers start to be different. So what I'm doing is I'm looking down the columns. So those are all 1s, all the same. I'm looking down the next column, all 3s, all 4s, all 9s, all 1s. But then at that next place, they are different. So that is going to be the numbers I zoom in on, if you will. I'll kind of ignore the rest of that stuff and just pay attention to where they start to become different. And so if I just act like what's in the boxes, what's in this, it's kind of hard to see it, what's in this pink box, I'm going to look at, well, if those were just plain old numbers, which one's biggest? I'm writing mine in order from greatest to least. And so I want to find which one's biggest. Well, in that box, that pink box, 90, 83, 99. Which one of those is greatest? Well, the last one's greatest, 99. So that means that whole number is going to be the biggest in my list. All right, so that takes care of that one. The next number, or the other two, I've got 90 and 83. Well, which one's bigger of those two? The top, the 90. So I'm going to write that one next. Now, I don't need to write in that 0 that I filled in. You're going to ignore that. That 0 is just to help me. And then, of course, that means the last one would be the smallest. And so that would be your answer. All right, the last one I want to talk about is the negatives. Just a big thing. Remember that negative numbers go in reverse order. So, for example, on the negative number line, I've got 0, -1, -2, -3, -4, and so on. You can think about your bank account. If you have -$1 versus -$5, the bigger number or the less negative number is going to be -1. So as you're moving to the left, the numbers are getting smaller in negatives, which kind of go opposite in the positive world. So in positive, 1, 2, 3, 4, 5, the numbers get bigger, but in negative, the order is kind of reversed, if you will. So the easiest way to think about this is they're still numbers, they're negative, but I'm still going to follow the same process. I'm just going to reverse the order. So I'm still going to line up the decimal places. And I'm going to write this one down below. So I'm going to write them all out with the decimals lined up. Okay, so those are all my numbers. I'm going to write them. Decimals are all lined up. And now I'm going through and looking if I need to add in any zeros. And so I need to add in some zeros here, here, and here. So I just went through and I add in zeros until the very last column is all full. That's where I want to make sure that all the numbers have something in the columns, if that makes sense. Okay, so now I'm moving to see what point do the numbers change? At what point do they become different? So going down each row, I've got 1, those are all the same. 4, those are all the same. 5, 0, 9, different. And so at this point, these are going to be the numbers that I focus on. Now, because they are negative, I'm still going from greatest to least, but in negatives, the smaller the number, the bigger it is. So just something to remind yourself. Never mind, I'm not going to write it. The smaller numbers are, hold on, Sally, hold on. The smaller that the number is, the bigger it is in negatives. So, hold on. So I've got 530, 530, 500, 53, and 930. So I'm just looking at these numbers highlighted in the box. 530, 500, 53, 930. So remember, I'm in negative world, so the greatest number is actually going to be the smallest up here. And so the smallest number would be 53. So my first one is going to be that third number. So I can take that off. The next smallest, but remember, I'm looking for the smallest number because I'm in negative world and it's backwards. So of the next ones, I have 530, 500, 930. So I'm looking for the next smallest. So that would be 500. So I've got that number. I don't need to write all of those zeros because I filled them in. So my math lab doesn't want that. So that takes care of that one. And then between the last two, I've got 530, 930. So the next one is going to be 530. So I've got that number. And then, of course, that leaves the last one to be the smallest. The big thing to remember here is that the smaller digits, I don't really know how to say that. The smaller if you take away the negative, the smaller that is, I don't like any of that. Just remember that the order is reversed. I don't like the way that sounds. That the order is reversed for negatives. And if you have the notes printed, we wrote that down earlier, but just to reiterate that it does go backwards for negatives. If you guys have questions, send me a text and remind or send me an email.